This is Christian de la Torre, and this is my presentation for CS 490 Senior Seminar for SDSU. Today we will be talking about flocking AI behavior and how to implement it inside of the Unity game engine. For those of you who already know how to use Unity, you're more than welcome to skip towards the end and see how I set up my scene with my scripts and my game objects. For those of you who have never used Unity, I'll be going over what I added and going over some of the code that I wrote for the flocking behavior. I've decided to demonstrate the code. I did want to decide to write it out, but I noticed that it took close to 30 to 40 minutes video lengthwise to do that, and so I thought I'd save you guys the time and shorten a little bit for you so you wouldn't get bored watching this. Now, something we'll be going over is some of the basic understanding of flogging behavior, the different kinds of styles, Reynolds algorithm, and some of in a demonstration as well, so you guys can get an idea of how it works. Now, as stated earlier, we're going to be going over flocking, the three different behaviors of that, consisting of separation, alignment, and cohesion, Reynolds algorithm, and then the demonstration. And then you guys can take a look at my resources, so in case you guys are interested in reading some of the material that I had previously read myself. Now, let's go ahead and get started. What is flocking? Flocking is like a group moving together in unison. Some of these examples could be a school of fish, a flock of birds, fly swarms. You see this a lot in movies, games, videos, music videos, in real life as well when you go outside and you see birds flying in a V formation, or whenever you see a school of fish swimming together towards whatever it is that they're looking to get to. A little fun fact, the flocking algorithm has been around since the mid-80s when it was first used to incorporate flying bats in the film Batman Returns. That is correct. Computer algorithms allowed for creating a flock of bats to come out of the cave when Batman is introduced, which is actually really interesting. Now, when implementing flocking behavior, you want to keep into consideration the three different styles so that your flock flows seamlessly without any kind of issues or problems. As stated earlier, some of these behaviors are actually separation, alignment, and cohesion. So, just to begin, we're going to be going over separation. What separation is maintaining a distance from other neighbors in a flock to avoid collision. Basically, making sure that your main boyd and all the other boyds around do not collide or mesh together so that it creates so that they don't overlay themselves. Otherwise, you get 20 birds or fish all coming together, and then it looks like there's only one target following the one boyd following the target. Next is alignment, the way in which the boyds move in the same direction and at the same velocity. Basically, making sure that all the boyds are moving in the right direction and not one moving more to the left or more to the right on their own. Lastly, we have cohesion. Basically, the maximum distance kept away from the center of the flock. Uh, you want to have a center dot to make sure that there's a little bit of space between all the boids so that you don't, like I said, have collision and it looks more normal. Now, getting into Reynolds algorithm, what Reynolds algorithm is basically the flocking A behavior that can be seen within the different movies, games, and videos. It also takes into account all flocking behaviors or styles, that is separation, alignment, and cohesion. The Boyd script and flock controller script that we'll be discussing later on in the video are basically the artificial life programs that simulate the idea of flocking AI. Boyd script will basically guide the Boyds, and flock controller will create the amount of Boyds that you want and how uh, you want them to be close together, far apart, and so that is all done within those two scripts. And of course, these can be modified to whatever you'd like. For example, we're going to be going over following a target using our Boyds, whereas you can do, if you wanted to, where the Boyds fly on their own to a specific location, and after hitting that location, move to a different location. Um, Kind of like follow the leader, but it's more of a lazy flight. And then there's also um, a different kind where you can have the Boyds fly in a circle or in an infinite loop. It's completely up to you to decide what you want to do. Now, for Unity, the environment that I decided to use was a regular terrain. It does need to be centered at the middle uh, for your X and Y, Z to be the terrain, the center of the terrain needs to be at 0, 0, 0. So what do I mean by that? If your width is 100 and your length is 100, you need to position X and Z at negative 50, negative 50, so that you get the center um, close to 0, 0, 0. As you can see in the photo, where you have the three axes, the three points of axis, it looks close to the center. And on top of that, that little blue dot is the cube, and that's positioned close to 0, 0, 0. Uh, and then you want to have the terrain close down to negative 20, negative 30. That way you have enough space in the y direction so that your target and your Boyds can fly freely. Some of the scripts I used were Boyd.cs, target movement, and flock controller. Now, Boyd and flock controller are Reynolds algorithm, whereas target movement is what allows the cube to move on its own and pick uh, locations that once it reaches there, it decides to pick a different one. And some of the main game objects were target, which is a regular game object, it's a cube. Boyd, which is a prefab, and it will need to be a prefab in order for this to work. And then flock controller, which is just an empty game object that will have both a transform or a transform, which is a target, and a prefab of the Boyd. Now, let's go ahead and take a look. Or actually, before I continue, here are my resources in case you guys want to take a look at that. Now, end that, and let's go into Unity. Now here you see that I have my flocking scene, the main camera, my light, the terrain, and my terrain is at, give me a second, has a width of 100 and a length of 100. and so it's positioned at -50, -20, -50. The y at -20, so like I said, my target and my boids can have some space to fly. My target is positioned at 347x, y0z0. It also has a target movement script attached to it. And then I'll be discussing more about this, but basically the move speed determines how fast it goes. The turn speed determines how quick it is to change direction. And a target point tolerance, all that means is how close does my target need to be to the destination in order before it decides to pick another location. And then I have flock controller. Flock controller is at 0, -5, 0. Like I said, you want to put these values, these objects close to 0, 0, 0 so that you don't run into any of the problems. For example, if these values are too high, your vector subtraction will not be accurate. And what I mean by that is that uh, your boids will fly at a direction that doesn't seem correct. For example, they might fly above the target and follow the target in an aerial perspective, or they just won't they'll completely fly away from the target. So you want to make sure that that's as close, both your target and your boids, or target and flock control are close to 0 as possible. Now, for the to go over this, I have the flock size. How many boids do I want? The speed modifier, which decides how fast the boids go, and then alignment, cohesion, and separation. Basically, what we talked about earlier to make sure how close they are together and how separated they should be. And then the follow weight, basically, what that is how close do I want my boids to follow the target. And then inside of prefab, all I did was drag boid from down here into there, and my target into, actually wrong one, my target up here down into here. So that's what I inserted there. The flock controller will have the flock controller script, and target will have the target movement script, and then the boid, the prefab will have, all it will have is the boid script, and that's about it. Now if we take a look, we see that we have a couple of variables. You have your target direction, which decides where the next step should be. You have direction, which is the boid's direction, and then you you instantiate flock controller, so that way you can get access into the flock controller script, and then direction, getting basically the direction of your boids, and then inside of awake, what you want to do is initialize direction, and then write a debug.log error to make sure that your flock controller is actually assigned and there's nothing, and that it's not empty. And then inside of update, you'll want to get the target direction, basically find out where the target is going by pushing basically this transform.local position in a direction. And then if the target direction is 0 at 0, then return itself. Basically what that means is that that just lets you know that you don't have a target on the map. And then we'll discuss direction, or this part, once we investigate flock controller. So inside of flock controller, you create your variables for flock size, speed modifier, alignment, weight. I do serialize the field of these. That way I can look at them inside of Unity right here. and be able to adjust these as the game is playing. And then I create a empty prefab so I can add my void into it. I also create a spawn radius and a spawn location, basically to decide how far apart these items should be from how far apart the voids should be from each other when they first spawn in, and where they should spawn in. And then three vectors for three uninitialized vectors for flock center, flock direction, target direction, and separation, as well as the public transform target to basically know where our target is headed and get its position at all times. And then because I'm trying to add these to a list, I create a list void. And then here we have public float speed modifier. All this does is get the value of speed modifier up here, and also allows you to get access to that value inside of void.cs. Now, inside of our wake, we want to create our voids, um, because if you do this inside of update, you're going to create multiple instances of void. So if our flock size is at 20, um, and for every frame of the game, you get 20 voids, and then another 20 voids, and then another 20 voids. So you get multiple voids, and so that kind of like that'll slow down the computer, um, and not only that, but slow down your game. And so you want to do it at awake because awake is called only once. Uh, I create a for loop, and then inside the for loop, I assign my spawn location a random. Uh, I create a random dot inside unit sphere, and then multiply by the spawn radius, and then add that to the transform that position. Basically, wherever my flock controller um, is where all my boards are gonna um, be located. And then after that, I then instantiate it uh, by what it is. So my prefab, my void, my location, and how they're rotated. And then I pretty much add them to my list. And then inside of public vector 3 flock is where I then allow the script to control the speed and direction of everything. So if we see here, we do flock controller.flock, and this is where it calls this. And so you'll have the void position, and the direction it's going. You then now initialize your direction center, your target direction and separation, and you create a for loop so that each void is assigned a direction, a center, and a separation value separately, and also to make sure that the neighbor that you picked is not the same one as the void that you first started off with. Then afterwards, you pretty much get the create values for direction, flock, center, and separation, and then you normalize these, because if you don't, then your value is off, will be off. You then get the target direction, basically the target's local position. For example, 3.4.700 minus the void position, wherever they're located. So 0, -5, 0. And then you multiply that by the follow weight, how closely you want them to be to the target. And then you return flock direction, flock center, and separation, and target direction to void.cs. And then inside of void.cs, um, direction of where the voids have to go will be equal to target direction dot normalized, and then you multiply by the speed modifier to make sure to test actually to see how fast they go, and then you do transform.translate to make sure that your boids are not uh, going at a rate that seems as if they are laggy. So that is that for boid.cs and flock controller. And then inside a target movement, you create a couple of variables. Actually, you don't need this bounds. You don't need that. You do have a movement speed, how fast you want it to go, turn speed, and then the target point tolerance. How close do you want your target to get to its position that it needs to get to before it chooses a different one? And then three vector threes for the initial position of where it is, the next movement, and wherever you want your target to go to. And then inside of awake, you're going to initialize your position to wherever your target is located at. So initial position will basically be, in this instance, 3.4700, and then you calculate the next movement point. So inside of calculate next movement point, you do a position.x, position.y, position.z, and you choose random values. Now these values will vary depending on how big your terrain is, but you'll want to keep these values close to uh, the same values as what your terrain width and length is, so that way they're inside the bounds. And then you initialize this to target position.x.y.z, and then it calculates the next movement point that it has to go to target position. Then inside of update, pretty much all update will be doing is getting those values. We'll get the value from calculate next movement point and use it to have the boid or the target movement move that to that location. So once that's all done and ready, what this ends up looking like is like this. And I'll show you here on this scene view because it's a lot easier to control. You'll notice the boids start grouping up together and start following my target. So they'll follow. That's pretty much flocking behavior, guys. And of course, like I said, you're more than welcome to, inside a flock controller, adjust these values accordingly to whatever you'd like. And pretty much use these values to however suits your needs. But yeah, that's pretty much it for flocking AI behavior. If you guys have any other questions, please leave a comment so I can take a look at it. If there is something that doesn't seem right, let me know as well so I can get that fixed. But yeah, thank you guys for joining me today. Bye!